And this is chapter 4 on central tendency, where we finally get to do some math for statistics. You're probably extremely excited, right? I can tell you're barely able to withhold your excitement. Nonetheless, here we go. Central tendency in distributions is what we're going to cover. This flowchart may seem overwhelming, but in the next couple chapters, you're going to be able to cover it and know it inside out. And knowing it inside out is extremely important because it will help you successfully answer a bunch of questions on the quizzes and the exam. This is the next chapter. Next couple chapters are going to deal with this part of the flowchart. For this presentation, I'm going to talk about this section right here, which reviews central tendency. And then this is a blow up of that section on central tendency, and something that I'm going to be referring throughout this presentation. Central tendency measures a typical score in a distribution, enables the researcher to summarize data as a single value and helping us to better understand what the data looks like. It's a value that represents the entire distribution, and somewhere in the middle, it will fall somewhere in the middle of most distributions. There are three main measures of central tendency. The first one is the mean, and that's the most common one that you see with most research that's reported. And of course, it's the average score in the set of data. The example I give is the number of correct responses on the memory test for the caffeine study, the famous caffeine study. And this, of course, is data from ratio scales of measurement. And as you'll see, depending on the scales of measurement that you use, it's best to report one measure of central tendency over the other. The median is simply the middle scores in a distribution, such that half the scores are above and half the scores are below that value. An example would be middle scores on an anxiety scale, where it ranges from not anxious, slightly anxious, moderately anxious, and extremely anxious. And of course, this would be from an ordinal scale of measurement. And the final one is the mode. So the mean is the average scores. The median is the middle of all of the scores. So just find the middle of all of the scores, right? And the mode is the most common or frequent score in a distribution. So for example, the number of yes-no responses on a questionnaire, which the book talks about, is a bimodal distribution. And that's an excellent stat to use for that, descriptive stat to use for that. Or top choice of transfer universities from a list of transfer universities that students are selecting, for example, at Bakersfield College. And those, of course, would be nominal scales because they're not ordered in terms of universities. So knowing those, remember the NOIR, N-O-I-R, nominal, ordinal, interval, and ratio are very important, as you can see. So everything that we've learned is kind of building on each other. So make sure that you know those like the back of your hand. What's up? What's the mean? So basically you want to use it with interval or ratio scales for measurement. It uses all the scores in a distribution in the calculation. Of course, it's the balancing point of the distribution. As you can see here, if there's 3 blocks here and 3 blocks here, it's the middle. And so, of course, in symmetrical distributions, where it's evenly distributed on each side, it's going to be in the exact middle. But in skewed distributions, the mean is adjusted towards the higher or lower scores. So as you can see, if we add one more block here, it's going to tilt things. So in order to adjust it, we move the mean, or the middle, the fulcrum, right, to the left, as you can see, to adjust for the skewed distribution. If the distribution of data is skewed, then the median is a better descriptive stat to use, as it's gone over in the flowchart. And if the questionnaire also has open-ended responses, then the median is better to use as well. Since the open-ended response renders the mean less meaningful, as the open-ended nature of the response makes the true mean impossible to find. For example, if you have 5 or more, we don't know if the participant wanted to select 5, 6, 7, 100. And so given that variability, we can't use the mean as we won't be able to know the true mean. And so that's why we use the median for open-ended responses on a questionnaire. And in terms of the skewed data, I'll go over in the median, but as you can see here, the median is going to be a better score because the skewing of data pushes the mean over towards the outliers. What are outliers? These are extreme scores, either high or low in a distribution. The outliers will influence means to a greater degree than the median or mode. Thus why in a skewed distribution you want to use the median versus the mode. Values pull the mean towards the outliers as the values change the mean versus the median and mode, which are influenced by the number of instances. So the values themselves are going to change the mean because we're adding them all up and dividing by them. So as you can see, the more extreme scores are going to affect the mean, whereas the median and mode are not values per se, they are categories, right? And so the median being what's the middle score in the categories, and the mode being the most frequent ones. And let's see where we're at. Distributions with outliers are skewed, of course. That's the definition, right? They're all on the outside, and so it's creating a high area in one area, whereas a low area in the other area, for example, or the middle. And important here that when you have a smaller sample size and you have more extreme outlier scores, you're going to have a more influence on the mean. The outliers will influence the mean much more. You want to become comfortable with all these symbols. Excuse me. And so what I've done is sort of just jotted down a lot of the symbols that we use just to become super comfortable with them. And so that's what we're going to discuss here, of course, other than the definition of the mean. Of course, the mean is you add up all the scores, and then you divide the sum by the total number of scores, and that's depicted here. The mean equals X with a line over it. So let's take a look what that is. That's the sample mean. Okay, that's the symbol for that. So the sample mean, not the population mean, the sample mean equals sigma, which is the sum of. So become comfortable with that symbol right there. Sum of, and X is the scores in your study, for example. And then N, small n, is the number of subjects in the study. So you add up all the scores and divide by the number of subjects in your study, and that gives you the mean. Similarly, there's the population mean. And so remember the X with the bar is the sample mean. Well, the population mean is this U with a drip on it, and that is the symbol for mu. And it's the same calculation, but instead of having the small n, you have large N, and you're adding up all of the people in the population and dividing, or all the scores in the population and then dividing by the number of people in the population. And so if we have the measurement scale, and you see mean right here, so we are using the mean, remember, with interval or ratio scales of measurement. And then we ask basically two questions. And the two questions will either lead us towards saying to the mean, use the mean, or use the median. One is there a skewed distribution? Now, there are a lot of outliers, and if there is, as you remember from the book discussion, it's better to use the median here, okay? Because those outliers are really going to mess with the mean and pull the mean towards the outliers, and the median is going to give you really a better representative stat of what you have. And then if there's open-ended responses, remember that kind of renders the mean in some ways meaningless because you can't get a true mean score. And so with that, you're going to use the median as well. So if you answer yes to skewed distribution and yes to open-ended responses with your interval and ratio data, then you're going to want to use the median. But if you don't have a skewed distribution, if you have a symmetrical distribution, and you don't have open-ended responses, and you're using interval or ratio data, of course the mean is going to be the most effective descriptive statistic for central distribution. So that was the mean, and what's the median? So again, I'll be referring back to this, but a really great chart here. You can see the median likes to use ordinal scales of measurement, as well as interval and ratio scales of measurement when the data is a skewed distribution or uses the scales of measurement. The survey responses are open-ended responses. So the median, it's a value where 50% of the scores in that distribution is that value or lower, and used with ordinal scales of measurement. Used with interval and ratio scales of measurement when the data distribution is skewed and or when the questionnaire has open-ended questions, like I had stated. The median is less influenced by extreme scores, making it a better descriptive stat for skewed distributions. And the median is needed for open-ended responses due to the fact that the open-ended response makes the true mean impossible to find, as I already reviewed that. And that kind of, again, goes into it. Is it ordinal data? Yes. Well, use the mean, or median, excuse me. Is it interval or ratio scales of measurement? If it's skewed distribution, use the median, right? And if it's open-ended responses on your questionnaire, use the median. And then, of course, calculating the median by hand is quite simple, especially when you have an odd number of scores. The median is simply the middle score when the scores are listed from lowest to highest, for example. And here, as you can see, the median is 55, as you have 4 scores here, 4 scores here, and in the 9 of scores, and 55 is in the middle. When you have an even number of scores, you don't know where exactly the middle one is, right? And so basically what you do is you take an average of the 2 middle scores, which is 53 and 54, and you have 53, or well, I did it wrong, didn't I? 53 and 54. It should say 53.5, not 54.5. Oh wait, we have these here. I didn't see those. So, let's see, we got 4, 5 here, and then 4 here, so it is in between those, 54.5. Okay. So the mode is the next one, and the most common or frequent score in the distribution. It's used with nominal scales of measurement, and it's easy to determine the mode from a frequency distribution table of a data set. As you can see right here with the percentages, and you can see that the mode is right here, which is support. And the number, frequency of scores as well, you can see here. So either way. It's useful when it differs from the median or the mean and the median. For example, if you have ratings asking participants to rate something on a scale of 1 to 5, but the majority of scores are either 1 or 5, if you have the mean, it's really not going to give you that good of a indicator of the data, right? Because it's just going to tell you in the middle, yet no one chose anything in the middle. And the same with the median is going to tell you either 1 or 5, depending on how many you have and where the middle one is. And so that's why the mode is really an effective thing, because it can tell you, how many, let's say, that are the frequent responses, which are 1 or 5 type of thing. And as you can see here, nominal scale for mode, and also in a bimodal distribution. Which I didn't talk about, but in a bimodal distribution, if you have like yes, no responses, where it's either yes or no, the mean is not going to give you a great calculation because it's going to be somewhere in between. But as you can see with the mode, it's going to give you, the number of instances of yes, number of instances of no. The most frequent number in the data set, of course, is the mode. And as you can see here, the mode occurs quite a number of times. The number 5 occurs quite a number of times in these scores. So it occurs 10 times, and therefore the mode is 5. So which measure of central tendency should you use? This again kind of goes over the flow chart, right? So if you have a symmetrical distribution, the mean provides a good representative value of the distribution. Of course, when we're talking about interval and ratio scales of measurement. A skewed distribution in these interval ratio scales of measurement, the median is going to provide a fairly representative value of the skewed distribution, excuse me, as the mean gets pulled to the direction of the skew. And this gives an example of the mean is 78.67. and the median is 80% there. So the median is going to give you a more representative value. So the median is preferred when the data is ordinal, when the data is open-ended, for example, responses are 2, 4 hour, 3 hour, 4 hour, 5 hour, or 6 or more hours, right? And I already talked about that. The mode is preferred when the data is nominal and when the data is bimodal. Mode is acceptable when the data is ordinal, and the mean is acceptable when the data is interval or ratio and has a symmetrical distribution. And this just summarizes it again. So you ask yourself, what's the best central tendency measure to use? So you take a look at your measurement scales for starters, right? And if you have a nominal measurement scale, then just use the mode. Or if you have a bimodal distribution. If you have an ordinal scale of measurement, use the median. If you have an interval or ratio scale, then you're most likely going to use the mean, unless one of two conditions exist, right? Or both. Where if you have a skewed distribution, then it's better to use the median because the outliers are going to influence the mean too much. And if you have open-ended responses, it's better to use the median. So I believe that's the presentation. Hopefully that helps and gives you some better ideas about the main concepts of the chapter.